Okay, today's lesson is 3.1, Solving Systems of Equations. So to make sure that you know what that is, y'all have done this before, so it should not be very easy. I'm going to go through it quickly, but the actual notes have all the examples worked out. So most importantly, remember just to email me or come see me, contact me in some way if you have any kind of question. Okay, so first and foremost, a system of equations is a set of two or more equations with two or more variables. And the solution of the system is a set of ordered pairs that satisfy all the equations in your system. So today we are talking about just two lines, and they can exist in a plane in one of three ways. So they here are pictures of those three different ways that they can exist. Okay. And what you got to remember, you got to be able to name these. So you want to remember that if the lines do not intersect at all, they have no solution, they're parallel, then we say that the lines are inconsistent. Okay. If they intersect at all, okay, these two intersect in one point. These two lines, they're the same line, so they have infinitely many solutions. But if the lines intersect at all, they're called consistent. So hopefully from there it helps you remember, but you also have to be more specific. If it is consistent, these two lines are independent and these two lines are actually dependent. And you're going to see the equation of that as we go through. You'll see what it looks like. Okay, so systems can be solved many different ways, but the first two ways we're going to talk about is either by graphing or using a table. And I'm going to start off with a table. So you would use ClassCalc, or you could use a scientific calculator these days. A lot of them have the table feature, which is quite invaluable. So when you get your equations and you put them in, and it is preferable if you do not have to rearrange these at all. So using ClassCalc or Desmos or something of that sort, that means that you can type it in just like it is. And you go to the table feature, and here would be an example of what you might see. Okay, so I looked at the numbers between -5 and 4. And when you're looking for, remember the solution is the set of ordered pairs that they have in common. So you're looking for the numbers that are the same. And as you look through this list, you see that those two y values are the same. And since they are, our answer is going to be 3, -1. All right, I was going to go to another one. So again, all right, you put up your table, you put the equations into your table feature of your calculator or device that you have, and you are looking for the y values that are the same, and they are right here. So one of the things to keep in mind also, okay, this is very, very important, but when you remember that the answer to all of these problems is an ordered pair, okay? When you look back up at this picture, our answer is a point in this problem. So if it is a point, then the answer should be the solution to our problem is an ordered pair. So you have to have parentheses around those numbers to let everybody know that it's an ordered pair. Okay. Solve each system of equations by graphing. So we did it by a table, okay? And I'm pretty sure y'all know how to do it by graphing, but just to talk about it real quick, I want to look at 2A here because these are they're in standard form, okay? And sometimes it is easy to graph in standard form. This one I'm actually going to do in a pink color. And if I do it in standard form, then the easiest way for me to do that is to go find, my bad, go find the x and y intercepts. So that would be if I plug in 0 for x, then I'm going to get 4 for y. And if I plug in 0 for y, I'm going to get 3 for 4. So you'll see when I graph that, or when I show you the graph, that those are the 2 points, and then I can use that to extend my line. Now, on the next one, it's not so easy. The reason we did that for the first one is because 4 and 3 both go into 12, but 6 and 4 don't go into 1, so not necessarily so fun. But one of the things I want to talk about before I go further with that is telling you how to solve an equation with, how to find the slope of a line in standard form. So 1 second, please. Okay, sorry about that. So what I was trying to say is when you have standard form, if these two, if A and B go into C evenly, then it's easy to find your X and Y intercepts. If they don't go in evenly, sometimes it's easier, to find the slope and then a point and graph it. So you can, by all means, solve that equation for Y, but we're on math team. Sometimes it is about speed and accuracy. So I want to refresh your memory, in case I haven't told you already, of how to find the slope in standard form and where it's coming from. So if you remember, your standard form is ax plus by equals c. And if I solve that for y, first I'm going to subtract ax from both sides, and then I'm going to divide by b. And so when I divide by b, then I'm going to have negative a over b times x plus c over b. And you can see now that that's like y equals mx plus b. So the slope of any line in standard form, it's a lot faster if you will remember that that's negative a over b. So if I take negative a over b, then that's negative 6 over 4, which is going to be 3/2. Okay, so, and then my y-intercept, b, is c over b, so it's negative 1 over 4. That's my y-intercept. So this is my graph. You can see my x and y-intercepts from the first line, and there's my negative 1/4 and doing a slope of 3/2. And I look at this point, okay, and y'all, the safest thing, if you haven't figured out by now, graphing is the least accurate method by hand of solving a system. So if you're ever doing it by graphing, then you want to find that point, and to find out whether or not you have the correct answer of 1.52 or 3/2 2, is you want to take this point and plug it into both lines to make sure that you have the right thing. Okay, so keep that in mind. Now, the other thing that you've got to be able to do is you're going to graph a system, and I'm going to, again, just talk about the logistics of doing that. And then you have to describe it as consistent and independent, consistent and dependent, or inconsistent. So to help me, I always draw pictures with this. And remember, inconsistent are those two lines that never intersect. And consistent means they both intersect. Consistent and independent means the lines are independent of each other, so they're going to cross. Dependent, one line depends on the other, so you're going to have the same line. So when I am looking at this, okay, again, standard form, 6 and 4 don't go into 15, so I'm going to go find the slope, and that's negative a over b, so that's going to be 3/2. And you can go do the next one. That slope is negative a over b, which is 3/2 again. So we have the same slope, which means it's not going to be this guy here. It's going to be one of these two. So I have to go find the y-intercept to see if it is. So this one I'm going to have 15 over negative 4, negative 15 over 4. And this one I'm going to have 18 over 4, which becomes 9/2. So from there, they're clearly not the same. So if you were to graph it, you should get that they do not intersect, and therefore the lines are inconsistent. Okay? Same thing, negative a over b, and that's going to give me 4/5. Negative a over b here is going to give me negative 2. Okay? Well, clearly they don't have the same slope, so these two are going to intersect, and when you graph them, you of course can put your y-intercepts in there, but since they intersect and have one point, then we call these two consistent and independent. And I don't know what happened there, but there we go. All right, so that was graphing that was solving systems using tables and by graphing. And now we're going to talk about doing it algebraically. You know this method. I'm just going to do 2 more examples, one of each type, okay? And then talk about some special cases, and then we're done. So substitution method. You have to solve one of the equations for one of the variables. It does not matter which one you pick. then you're going to substitute the resulting expression into the other equation to replace the variable and solve that equation. And then you're going to substitute back in to solve for the other variable. So for number 4, I'm choosing to do 4C. 4A and B are worked out for you on the calendar if you want to go see them. So what you do is it said pick an equation to solve for a variable. It does not matter which of these two we choose, but you do make your life easy, y'all. Go find the one that has a coefficient of 1. So I'm not going to solve for x. I'm going to solve for this y. And I know y'all know how to do that. So when I do, I'm going to get y equals negative 6x minus 27. Okay? And then the next step is to substitute. So I'm going to take this expression for y, and I'm going to go plug it into the other equation right there for y. So when I write that down, I'm writing everything except for the y. I'm going to put parentheses, and what's going to go in my parentheses is negative 6x minus 27. So then I'm going to distribute. So 8 times negative 6 and 8 times negative 27. And then I'm going to bring the 216 over and combine my x's. So that's going to give me negative 45x equal to 225. So x equals negative 5. And then, easiest, y'all, you can take this x equals negative 5 and plug it into either one, but you've already solved for y. So it is somewhat easier to use this one. So that's what I normally do. So I put in y equals negative 6, and I'm plugging in negative 5 for x, and that gives me 3. So my answer, you cannot leave it. X equals negative 5 and y equals 3. The answer is always an ordered pair. So my ordered pair is the x value and then the y value. Now, if you want to check it, y'all, you know that this point works here because that's how you found it. So if you really want to check yourself, then go plug it into this equation and see if it works. And if you do, you'll see that it does. Okay, that was substitution. Elimination, you already know it. Okay, I don't know why I did that. Okay, so elimination, you're going to multiply one or both equations by a number to result in two equations that contain opposite terms so that when you add them, one variable falls out. So that's why we add the equations, eliminating one variable, and then solve the resulting equation. And after that, we're going to substitute to solve, so it's very similar to what we just did. All right, so in this example, I'm going to do 5b, and the main reason I did that, these were kind of easy examples. Those are already opposites, not much to do but add them together and they fall out. I look over here, again, add them together and they fall out. So here, I can't add them together. So technically what I'm doing is multiplying by -1 and adding them, but I just choose to subtract them. And I encourage you to put the parentheses around it because you need to remember 6 minus 4 is 2x. That's not what I wanted. 6 minus 4 is 2x. And of course, the 5 y's fall out, and -8 minus a -12 is -8 plus 12, which is 4, and you already saw it. So x equals 2. And here, y'all, does not matter which one you plug it into. I'm looking for y. They both say 5y. You might choose the one that has smaller numbers. It does not matter. Okay, so I plug it in. I'm going to plug in 2 for x because that's what I just got. When I simplify it, -5y equals -20, so y equals 4. And my answer is the ordered pair 2, 4. Okay, two last things we got to talk about, and then we're done. And that is, what happens if we have no solution or infinite solutions? So solve this system, standardized test, you might see this, okay? You can get a graphing utility and graph it and know the answer because we talked about that at the beginning. But if you had to do it algebraically, it's important for you to understand what you're going to see, which is not what I'm talking about so much, but you could. I would look at this first before I did it algebraically, and I'd say, okay, the slope of that first one is -5/3. And the slope of that second one, -a over b, is -5/3. They have the same slope. Well, if they have the same slope, it can't be a or b. So then I'm going to go, okay, c over b is my y-intercept, so -52 over 5, and 54 over 9 simplifies to 18 over 5. Well, those are different ones. So same slope, different y-intercepts means that my answer is no solution. Okay? And the last one, when you look at this, okay, the easiest way, y'all, is if you look at it and say, oh, 2 times 3 is 6, 3 times 3 is 9, and 5 times 3 is 15. Well, that means that's the same line. So you know what the answer is. But if you didn't see that, you could go find the slope of each one and find the y-intercept of each one, and you'd find that it's the same. Okay? So at the end of the notes, the very end, you'll see your homework problems, but here is a summary of what we've talked about with solving system of equations and what you should know how to do. So if you have any questions, please don't hesitate to come see me or email me. Thank you so much, and y'all have a great day. Bye.